Very excited to be here. Good afternoon, everyone. My name is Sebastian, and I'm joining you from our office here in Amsterdam, downtown on the Marnixstraat, in the middle of our Creative Technology Lab. We have an exciting presentation prepared for you today. We will start with some brief introductions of Marco and myself, then set a bit the stage on extended reality, and then directly dive into the content because we got some exciting stuff lined up for all of you. Now, Marco, I would like to give it to you to start off the introduction.
Terrific. Thank you very much. And thank you for the warm welcome and joining our session here at ESA. As you already heard, my name is Marco Tempest. I work at Accenture, leading their extended reality practice in Zurich, Switzerland. And I work with augmented and virtual reality, gestural sensing, robotics, augmented intelligence, and a whole host of other interesting technologies to create experiences that are clear, memorable, and also seemingly sometimes impossible. In other words, I help our clients and our organization bring their technological stories to life. I also wear a second hat. I work at NASA's Jet Propulsion Laboratory as a creative technologist. There I support technology development, proposal design, education activities, and in particular I help robotics groups deliver novel user experiences based on advanced technology concepts. Thank you very much for having us.
Brief intro on myself. So my name is Sebastian Veldman. I'm the innovation lead here at Accenture Interactive in the Netherlands. Been working with the European Space Agency actually for the last 3 years. Starting off on a project called AstroPlant, as some of you might know. It's a citizen science project that focuses on studying plant growth, vegetable plant growth, and how that knowledge can be transferred for future space travel deeper into space. Here's a picture of myself together with Adam Savage of Mythbusters when we presented AstroPlant in Las Vegas. It defines a bit also my role in the team that I manage here at Accenture Interactive. We have both people with a technology background and people with a design background. And I'm very lucky to work with all of this great talent to find the right projects for them, challenge them on their skills, and constantly innovate on the latest on both technology and creativity. Today, we'll be talking about one of my favorite topics, extended reality. And as I mentioned, I would like to do a brief intro before we really go into the project so that you all understand what it is that we're talking about. So extended reality, or better known as the abbreviation XR, I'll be referring to it mainly XR throughout the presentation. What is it exactly? Very simply, in one slide to explain it, you could say it's a spectrum of immersive technologies that we probably have access to nowadays or have heard of or seen examples of. Augmented, mixed, and virtual reality basically define extended reality as the full spectrum. Augmented reality can be found in smartphones nowadays. So on your iPhone, you got this amazing set of cameras that allow you to basically beam three-dimensional content in any space that you're currently in. We have mixed reality, which is basically a term used by Microsoft that allows you to put on a headset and then basically use depth sensors to create interactive three-dimensional content in the space that you're currently located in, or actually connect yourself with other people as holograms around the world and have a virtual meeting as if you would be physically together. And virtual reality is really leaving the physical world and entering into a full virtual environment, so you have no awareness of your physical arousal. You're completely beamed into a world that has been designed based on the purpose that it needs to serve, and throughout that world you can interact and do trainings or have entertainment depending on the purpose of that specific experience. We'll be tackling a bit of everything throughout this presentation, so we'll try to highlight what devices have been used and for what use case specifically. Now, for Accenture, this isn't a small practice. Nowadays we have around 300 extended reality professionals scattered throughout the globe. They're working in more than 50 nowadays global XR centers. That means we have development capability there, we have design capability, and we try to bring those skill sets together to create amazing experiences for our clients. We've won some awards. We write a lot of thought leadership that we share throughout white papers. Our technology vision, for instance, is one of those. I highly recommend you to have a read in it because extended reality is a very important component of it. But we also work with a lot of partners to make sure that we have access to the right devices, or that we work with the latest software so that we ensure that the experiences that we create are top-notch and really take the most out of the device that we are working with. As I said, we're everywhere around the world. All these centers have access to both hardware as software, as amazing skills in the people that occupy those centers to make sure that we can deliver wherever we are around the world, together with the partners that we closely collaborate with. Now, to give you a couple of examples on projects that lend to extended reality, I'll start up with an augmented reality example. The project that I'm showing you here is a project that we've done for Hyperloop. It's a startup here in the Netherlands that focuses on Hyperloop transportation. The project that we took on was called the Cabin One Experience. And as you can see on this slide, it's basically a segment, 8 square meters to be precise, that represents the actual interior of a future Hyperloop vehicle. This segment is used for research purposes. So Hyperloop intends to transfer this demonstration to various conferences and meetings to expose it to people that can give feedback and share ideas on how the future transportation vehicle should be looking like and what type of services it should entail to make sure that the future traveler really has everything it needs to travel from A to B in a sustainable way. Now, on the other hand, it's a small segment to try to imagine what this could all bring and the opportunities it could offer. We're missing a lot of things. And that's where technology comes in. So the project focused from our end on bringing the digital experience on top of the physical layer that you see in front of you. So by simply holding your iPhone or your iPad towards the demonstration that you see here, we can basically supplement the missing pieces by adding a digital layer on top of it. So by simply pointing my camera of an iPad or an iPhone towards this 8 square meter demonstration, I can basically add all the missing pieces and allow people to basically virtually explore all the details that the Hyperloop will bring and dive into any areas that might trigger their interest. Now that really creates an exploratory feeling because you can walk in any direction, zoom in or zoom out. It's a lot of freedom that you have in exploring the Hyperloop. But there's also another angle to it, and that's by actually sitting into one of the chairs of this demonstration and using the HoloLens in this specific example. Because we take basically the same experience, but then from a first-person point of view. So as a traveler sitting in the seat, the HoloLens will basically supplement virtually all the missing parts of the Hyperloop vehicle around you and will unfold the story on how it will be from traveling from A to B in a Hyperloop in the nearby future. The second example that I want to share with you is a concept that we're currently pitching with NASA, which is called the Globe Observer app. It's an existing app that NASA uses to basically collaborate with citizen scientists to gather data of clouds around the world. There's a problem though, because people are not that incentivized to make pictures of clouds and share that data with NASA, let alone using the app. It can be quite a challenge because it requires a bit of technical expertise to successfully use the app. So we took that opportunity basically and proposed a new concept to NASA by introducing gamification into the concept, and gamification connected to augmented reality. So what if we would use the camera on your iPhone or iPad, allow you to point it up into the sky, show you what the eye cannot see. So for instance, satellites that are crossing by. So sparking a bit of curiosity with the user, allowing them to do a bit of research about the things that they're seeing in the sky that the eye cannot capture, while at the same time identifying clouds throughout artificial intelligence and helping them to map that data of that specific cloud and give it back to NASA so that the scientists can work both with satellite imagery as imagery from the ground captured throughout the Globe Observer app. That's the way we would like to use augmented reality in this specific example. But there's so much more, and I'm really excited that Marco is with us because I'll be giving the screen to him, and he will be walking you through several examples.
Thank you, Sebastian. We're going to talk a little bit about extended reality for robotic space exploration, which really can cover the whole gamut, a mission lifecycle management almost through insertion of XR experiences. So you can go from formulation through design and development into launch and even operations using these kind of tooling and these kind of tools. So I prepared a few examples of what JPL is doing in this respect to give you a glimpse on kind of the art of the possible. And the first thing I'd like to share is Protospace, which is a collaborative visualization tool for design, formulation, and spacecraft assembly, an experience which runs on a Microsoft HoloLens. So here's a short video.
JPL is using it to allow designers of the next Mars rover to take their plans off the computer screen and think about them in 3D at full scale before anything is actually built.
We have to build this thing here on the ground, and people have to get around it. You have to be able to put your arm in like that and turn a screwdriver, for example. And that's a hard thing, or at least a time-consuming thing, to check on a 2D computer screen at a smaller scale. We can place pointers on the model, on the hologram. For example, if we want to talk about that antenna, I can place a pointer there, and you see it, and I see it, and everybody that's participating in this session will see it.
And these pointers really do get over the final drawback to the mixed reality experience, the fact that you can't actually touch the 3D model. I dare you not to imagine this changing our world.
Another example is OnSite. It's another HoloLens app, an augmented reality app. It's a science targeting tool which allows scientists to meet on Mars for virtual field trips. And I have a little video about that as well. And here you can see how this plays out. So we have a scientist putting on a HoloLens and stepping out onto Mars. And the topography he's seeing is not an artist representation. This is actual terrain which is created from images which come from our rovers and which are in an automated pipeline put together overnight, every night, into the latest topographic information for these virtual field trips. And making the surface of Mars experiential, where you could say data becomes media and you can just interact with it like you would be truly there on Mars. A fantastic implementation of an XR environment for scientists. Now, a derivative of this tool is Destination Mars. So we take it here from operations into outreach. We use the same data product and created a mesmerizing experience for the general public, which takes place at the NASA Kennedy Space Center. And here's a short video which shows this application.
Mars can be a lonely place. So we've created holographic captures of an astronaut and a member of the Curiosity rover team to be our guides on this journey. And this gave us an opportunity to immortalize a hero.
Hi there, I'm Buzz Aldrin.
To help Buzz explain how we're doing science on Mars today is Curiosity rover driver Arissa Hines.
Welcome to my office.
We can put the public, the rover and Arissa together at the exact place where Curiosity made some of its most amazing discoveries.
Let's go to Mars.
The next thing I'd like to touch on is another HoloLens collaboration with Microsoft. This project is called Sidekick. It's a tool to augment and assist astronauts on the International Space Station as they perform tasks. So a team at JPL has actually flown a HoloLens device on the International Space Station in 2015 and have a short video of some of the tests in a zero-G flight where you see the team of Microsoft and JPL and some astronauts testing this capability before this solution flew on the space station.
Sidekick. Accept.
So what I've shown so far are kind of lighthouse projects, like large teams or awarded missions interacting with extended reality, big outreach projects. But there's also the possibility for smaller teams very early in their project phase to use extended reality capabilities to help with funding, to bring on board stakeholders, help with their storytelling, or how we call it at JPL, with their compelling mission narratives. And a good example is Eels. Eels is a swimming robot. It's a mission concept of a robot with a very unusual morphology and a amazing autonomy concept. And so this team, this small team, has used extended reality in all phases of their mission development, from formulation through design to even forecasting some of the concepts of operation. And I want to show you first a small example of creating a mission video, a mission narrative, a concept video using extended reality capabilities. And in this particular case, they used a game engine technology to create a very high fidelity concept video in a very, very short amount of time, like bypassing the typical Hollywood render pipelines you have on these kind of videos. So in other words, the video samples you see here, they play in real time on a system and can be altered and changed very, very quickly. So iterations are possible. And I'm going to hand it over to Kaylin Carpenter, who is the PI on this project. So here are a few samples.
Let's take a journey through our mission concept. Targeting the jet with the greatest mass ejection, a spacecraft will land near the plume exit. From this, the exobiology extant life surveyor, or Eels robot, will deploy and traverse to the edge of the vent opening. It will assess its surroundings and anchor to react to plume forces before placing its sensor head into the plume streamline. From this, we will attain a huge amount of information about the mechanisms driving the plume and the liquid below. By adopting a spiral configuration, Eels adapts to the undulating terrain. It reconfigures itself based on the reactive forces measured, maintaining outward force, ensuring constant grip. The vent most likely constricts to a throat. Eels is designed to adapt to this, becoming a self-driven screw, able to power through this point of greatest force. Once through the throat, the liquid water is near. This is the predicted high tide point where boiling of the ocean or gas exhalation from the liquid is driving the plume. Once in the liquid, Eels swims, using the instruments to see if it swims alone. And maybe one day, venture deeper to hydrothermal vents, possible alien nurseries of life.
So you can see very high fidelity, explaining a very complex morphology, and also even hinting at possible data products for on a possible Eels mission. Now the same data set was used to create an iPhone application to visualize Eels at life size, at full scale. So this you see here is running on an iPhone. You see a sheet of Enceladus ice, and you see eel at real-time scale, at real-life scale. And so stakeholders, funding sources, review boards, imagine a virtual site visit, can interact with the spacecraft before it's even built. And then finally, another aspect of using XR was the future concept of operation. So how would a dashboard look like? So here again, a game engine is used to create an operator dashboard which shows the autonomy concept, how the sensor head works. It shows robot health and implies the the concept of having an introspection layer with AI between the operator and the spacecraft. So very interesting, like end-to-end mission lifecycle management using XR. The final example I'd like to show is a new capability which is coming online really rapidly, which is called virtual production, where you can immerse yourself or insert yourself into your future missions. And I created a short video for JPL, which I like to play to show you how this capability works and how it can be used. So I'll play the video. It's cold here in virtual Antarctica. So I'm currently in a virtual set and I'm controlling it with a clicker in my hand. And I can move around freely in this Antarctica virtual Earth analog fields test environment. I created a few other examples, so I want to take you on a quick tour around our solar system and show you some of the fidelity and possibilities of using this technology. So here we are, one of my favorite mission concepts. It's Eels, the exobiology extant life surveyor. We're on Enceladus. I'm next to the Gamma lander, not quite sure if this is 100% accurate, but just to give you a taste of how it would feel like to interact with a future mission concept and make it tangible to an audience online. So spectacular vistas here on Enceladus. So I think we're ready for the next location, so here we go. Our next destination is Mars. Behind me approaching is Curiosity. I'm fully immersed on the surface of Mars, presenting and interacting with our incredible mission. Before I get too dusty here, let's go to our next location. To here, this beautiful imaginary space station we created. So this is how it would look like if you turn around and look out the window or spin back to the audience. This is how it looks like kneeling down, touching the floor, pointing at things, taking a few steps to the left or to the right. So there's a fair amount of movement that is possible, or gesturing as well. So after this quick trip around our solar system, I want to show you how this actually works. So I'm currently inside my basement in front of this green screen backdrop. It's 2 tripods, a piece of fabric, 4 lights, and a camera. It sets up in about 20 minutes. Footage then gets recorded just the way this looks right now and can then be inserted into my virtual production environment. And I can, with a click of a button, now transform this footage into virtual sets technology, where you can be on site inside a virtual environment. So if you got curious, please reach out to me. Meanwhile, I wish you all an incredible 2021. Thank you very much. So this little taste of virtual production technology, I like to bring it back into the world of Accenture for a moment and talk a little bit about the tooling that goes into creating these kind of experience and how we set up at Accenture to make these experiences possible in a very quick and in a co-creation type of way with our audiences and with our clients. We created an internal platform, an accelerator, which we call the Accenture Immersive Collaboration Platform. That platform works on various types of devices. It works on virtual reality headsets, which are portable. They're about like 300 euros, one of these headsets. You put these on and you're immediately fully immersed into a virtual world. But it's multi-platform, so it also works on Macs, on PCs, on iPads. And we use this solution to visit our clients virtually in our beautiful flagship innovation locations all around the world. These locations are currently closed and we cannot bring clients and our personnel into these locations. So we use virtual reality to host virtual workshops. We have small plenary rooms where we can host meetings, and we have many of these locations all around the world which we have created where we can meet and we can teleport from one to the other. And I'm going to show you a little bit how that looks like in practice. So here you see multiple users joining in an ICP session in this immersive collaboration platform environment. They meet for a plenary room, they interact, they can teleport from place to place. And what we found out using this solution is that a lot of our employees are actually missing the places they work at. They have meaning to them. They're proud to be at their studios and meet with their co-workers. And being stuck at home is a somewhat cultural loss. So we created this solution not only for our clients, but also for our employees to meet together in the places, in the digital twins of the places which are relevant to you, and co-create and innovate and have a jolly good time, so to speak. I'm gonna stop the video here and hand it back to Sebastian.
Thank you, Marco. Thank you for all those amazing examples. So ways to collaborate with us. Well, you will have our details after this call, so you can always reach out to either Marco or myself directly via email. And that's it from my side.
Space time.